You may want to create for yourself a little running list of things that we're using that will need to be memorized for this quiz. There's actually several things that you'll need to know. For the first group of questions, the first piece of information we need is the third side of the triangle. How do we find the third side of the triangle? Pythagorean theorem. So that would be the first thing that I would put on that list of things that you need to know is the Pythagorean theorem. A squared plus b squared equals c squared. When we plug in the values for the first example, we end up finding that third side is 5. 3, 4, 5 is kind of a special triangle for us. It's one of those things that if you learn to recognize, it can be a time saver because then you don't have to go through the process of the Pythagorean theorem and possibly make a mistake in doing that calculation. But it's not necessary that you memorize it. Then once we have the three sides of the triangle, we need to label them according to the relationship of theta. So which side is the opposite? And the adjacent? And the hypotenuse. So then the next thing to add to your list of things that you need to know or have memorized is SOHCAHTOA and also their reciprocals. When you create your lists, please use the full appropriate 3-letter abbreviations. I'm probably one of the laziest people that has ever walked the earth, and I'm telling you that it is important enough that I want you to actually write all 3 letters instead of just writing the first letters. Okay, some students have been abbreviating with just the first letters on your homework, so make sure you write the full appropriate 3-letter abbreviations. So for SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Questions? Go ahead and try the next 2. To use my Pythagorean theorem on it, we need to make sure we set it up correctly. Big mistake that students make a lot. What is important about the Pythagorean theorem? C is the hypotenuse. So we have to do 5 squared plus b squared equals 13 squared. A and b don't so much matter. Call it whatever letter you want to call it. But you have to make sure that that hypotenuse is c, that that's the one that's alone. When we solve this out, we should find 12 for that third side. 5, 12, 13 is also a pretty special triangle. Again, not something that you have to memorize, but if you learn to recognize it, it'll save you time and possibly miscalculations because you won't have to do the Pythagorean theorem on it. 5 is the adjacent, 12 is the opposite, and 13 is the hypotenuse. So then sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. Cosecant flips over sine, secant flips over cosine, and cotangent flips over tangent. For the third one, when I do the Pythagorean theorem, 11 squared plus 11 squared is c squared. Gives me 242, which is not a perfect square. So we want to simplify this down. 242 is divisible by 121, which is a perfect square, to give 11 square roots of 2. This is actually a special triangle as well. I didn't tell you to memorize like 11, 11, 11 root 2, but what kind of a triangle is it?
45, 45.
It's a 45, 45, 90. If you notice that 2 sides of a right triangle are the same, it's an isosceles triangle, it must be a 45, 45, 90. So you can just throw that square root of 2 onto the hypotenuse then. So that'd be a time saver. Again, all three of these were special nice triangles, I promise tomorrow they will all be special nice triangles as well. Not necessarily the exact same, but they will be special nice triangles. So since you're not going to have your calculator, if you recognize those patterns, it can save you having to do some arithmetic. Now when you go to do your SOHCAHTOA here, sine is opposite over hypotenuse. Reduce your fractions. So we just get 1 over square root of 2. Cosine, likewise, would be the same thing. So reduce. And tangent would be 11 over 11, which is just 1. When you do your reciprocals, cosecant will flip to just give a 2. Secant flips to just give the root 2. And cotangent flips to just give the 1.
Would you mark this off if we just wrote the square root of 2 over 1? Like,
No, if you leave cosecant and secant as square root of 2 over 1, that's fine. I want them as reduced fractions, so like for sine, don't leave it as 11 over 11 root 2. But if you leave something over 1, I won't mark that wrong. Other questions on this problem, or this type of problem? Next is our conversion. So this is another thing that you might want to add to that list of stuff to memorize. You need to know that when we convert, 180 degrees is equal to pi radians. So that's our conversion factor, just like 12 inches equals 1 foot. 180 degrees is pi radians. So to convert, I always put it as a fraction over 1 if it's not. Multiply so that what we are given will cancel. So I'm going to put degrees on the bottom, which puts pi on the top. And this reduces just down to pi. That is our conversion factor. 180 degrees is equal to pi radians. For the next one, there's a fraction. Degrees goes on bottom, so it'll cancel with pi on top. And then we need to reduce. How many times does 30 go into 180? 6. So we get pi over 6. It's one of our special angles because of the 30, 60, 90. 3 pi over 2. I'm going to put pi on bottom so it will cancel, which puts 180 on top. Now we have a little bit of arithmetic to do here. 2 divides into 180 to give 90 times 3 gives 270. This is actually a special angle for us as well. Why is 270, 3 pi over 2 a special angle?
because it's one of the
It's one of our quadrant lines, right? It's the straight down on our unit circle. So those quadrant axis lines going around are important to us for the unit circle, and 270 is one of those unit circle values. So 270, 3 pi over 2 is an important angle. 6 pi, put it over 1. Multiply so that pi cancels, which puts 180 on top. I don't know what 6 times 180 is, so off to the side, I'm just going to show my work here. Get 48 and 1080. So if you are into watching any sort of extreme sports, when they say they did a 1080, that's 3 full revolutions. That's where the number comes from. 6 pi is 3 full circles. For number 8, it already is a fraction. So I'm going to put the pi on bottom, 180 on the top. And what do I get? Negative 90. Don't lose that negative. It's really easy to lose that negative. Also, negative 90 is coterminal with 270. We talked about how that means they end at the same place. But I don't want you to change into coterminal angles. I just want you to convert. Just give me exactly what that value is. So don't change this into 270, even though, yeah, they're the same thing on the circle in a graph. I want the actual value of the conversion. 140 is not any sort of a special angle for us. Let's put it over 1. 180 goes in the bottom, so we can cancel those degrees. And then we want to reduce as much as possible. So I can reduce them both by 10, get rid of those zeros, and then what about 14 and 18? They reduce by 2 to leave
7 pi over 9.
7 pi over 9. And the last one of this type, pi goes on the bottom, 180 on the top, so we can cancel off those pi's, and then we have some arithmetic to do. You can do either part first. You could multiply 180 by 4, or we could divide by 5. I like to divide first because that keeps numbers smaller instead of multiplying first makes them bigger, but that's just a preference thing. I have no idea what 180 divided by 5 is, so I'm just going to show my work. Goes in 3 times, which leaves 30, goes in 6 times. So I get 36 from the division, and then I multiply that by the numerator 4, and I get 144. My answer is 144. So if you have a small 4-function calculator, just add, subtract, multiply, divide, you can bring it and you could do this on your calculator. If you don't have one and you're starting to panic, like I can't do anything without my calculator, just show me what you're doing. If you show your work like I was showing my work here and I can see you knew what you were supposed to do and it was just a miscalculation, it's not going to be a big deal. Okay, so don't panic over arithmetic, but if it makes you more comfortable to have a little calculator and you do have one, you can bring that. But no calculators that have sine, cosine, and tangent.
Will you mark this off if you don't put the little degree circle?
No, if you don't put the degree circle, I wouldn't take anything off. All right, next type of question. For this next question, there's a couple more things that you need to add to your memorize list. You need to know that circle with our special axis angles. We'll draw it as we need it in questions. And you need to know your 30, 60, 90, and 45, 45, 90 triangles. And that will finish off our list of stuff to be memorized. So you need to know the Pythagorean theorem. You need to know SOHCAHTOA and the reciprocals. You know pi radians is 180 degrees. You need to know your circle, 30, 60, 90, 45, 45, 90. So, first step is to graph the angle. So if I graph 270, where does it end up? The bottom line, 270, goes around 3 quadrants of 90. When my angle lands right on one of those axis lines, that's when I need my circle. This point on the circle would be what? It would be 3 pi over 2 as far as the angle line goes. 3 pi over 2 is equal to 270. But what would that point value be? 0, negative 1. Over 0, down 1. How does that help me with trig? What does that point mean? Cosine, comma, sine. It's alphabetical. So in this question, we're asked for the sine value. So what is that? Negative. Okay, for 225, if I graph that, where does that land? In the 3rd quadrant. How far past the 180? 45. Connect up with the x-axis, always the x-axis, to make a right triangle. 45, 45, 90 needs to be memorized. What are the sides of the 45, 45, 90? 1, 1, and square root of 2. Anything need to be negative in this triangle?
The top and the bottom.
Both ones, left on the x-axis, down on the y-axis, are negative values. Hypotenuse is always positive no matter what it looks like. What's SOHCAHTOA for tangent?
Opposite of adjacent.
Tangent is opposite over adjacent. And so in this triangle, what is that? Negative 1 over negative 1, which is just 1. Seven pi over 4. How do I graph in radians?
Make 4 pieces on top and bottom.
Whatever the denominator is, make that many pieces on each half, top and bottom. The numerator tells you how many pieces to go, so I'm going to go around 7 pieces, which puts me into that 4th quadrant. And what kind of a triangle is this? 45. So 1, 1, and square root of 2. Any negatives? the vertical one. What's SOHCAHTOA for sine? Opposite over hypotenuse. So what do we get? -1 over the square root of 2. The -1 is the opposite one. Square root of 2 is the hypotenuse. Tangent of 0. It doesn't tell us whether it's 0 degrees or 0 radians, but it doesn't matter because they graph or just don't go anywhere. So that points straight out to the right. When we land on one of our axis lines, we need our unit circle point. What is that point on the unit circle? 1, 0, which is cosine sine, but we want tangent. What is tangent equal to? Sine over cosine. So sine is 0, cosine is 1, which gives us 0. What about zeros on the bottom? Undefined. Now look at one more of this type of question together. I want to look at the sine of 4 pi over 3. If I graph 4 pi over 3, what do I do?
You would divide the top and bottom into 3 sections.
Top and bottom into 3 sections, which means we want to ignore that vertical. The vertical doesn't help us break into 3 sections. And I'm going to go around 4 pieces. So that puts me down here. How big is the reference angle?
30 degrees. No, 60 degrees.
60 degrees. 180 divided by 3 is 60. So 30, 60, 90 is something that needs to be memorized. What are the sides of the 30, 60, 90? 1, 2 and the square root of 3. Make sure you memorize it correctly. 2 is the hypotenuse. Really common mistake. 2 is the hypotenuse. So make sure you memorize that correctly. 1 goes across from the 30 because it's the smallest. Hypotenuse is 2. And square root of 3 for across from the 60. Anything need to be negative here? Okay, left and down is negative. What's SOHCAHTOA for sine? And what does that give me then? Okay. Questions? For this last type of question, there's nothing new that you need to have memorized, but we're going to use, again, our special triangles and our unit circle to solve the questions. So first thing we do, also with SOHCAHTOA, is think about a fraction. If it's not a fraction, make it a fraction. Put it over 1. What's SOHCAHTOA for sine? Opposite over hypotenuse. Which triangle has a hypotenuse of 1? There isn't one. So this method is not going to work for us. So if it's not in a triangle, where is it? On the circle. So if it's a sine value, which part of the point are we talking about? The second, because it's alphabetical. Cosine, comma, sine. Which point on the unit circle has the second value as 1?
0 or 360.
90. At 90 we have 0, 1. So our answer is 90 degrees. Directions say to also give in radians. How many times does 90 go into 180?
2.
2 times.
Did we learn this stuff yesterday?
SOHCAHTOA for tangent is what? Opposite over adjacent. Which triangle has a 1 and a root 3? 30, 60, 90. So in that 30, 60, 90, which one of those angles is opposite of a 1 and adjacent or next to a square root of 3? The 30 is opposite of the 1 and next to the square root of 3. How many times does 30 go into 180? 6 times for pi over 6. What's SOHCAHTOA for cosine? Which triangle has a hypotenuse of square root of 2? 45, 45, 90. In the 45, 45, 90, your answer must be 45 because 90 cannot be an answer from a triangle. So if 90 is an answer, it's coming off the circle as it did in the first question. 90 doesn't work in triangles. So if you know you're looking at the 45, 45, 90, your only possibility is 45. How many times does that go into 180? 4 times for pi over 4. If you have a negative value, you know you're going to be looking at the circle because we haven't talked about drawing the negative triangles. So in the circle, alphabetically, sine is the second part of the point. So where in the unit circle do I have a point with the second part as negative 1? At the bottom, 0, negative 1. What is the angle at the bottom of the unit circle? 270, which is equal to how many 180s? 3 pi over 2. It's 1.5 180s. I'll make this into a fraction with SOHCAHTOA for tangent. Opposite over adjacent. Is there a triangle that has 2 ones if I don't care about the hypotenuse? The 45, 45, 90 works here. 2 ones, and it doesn't matter what the hypotenuse is. So if it's 45, 45, 90, it has to be 45, which we said before is pi fourths. For the last one, what's SOHCAHTOA for cosine? Adjacent over hypotenuse. Which triangle are we looking at? 30, 60, 90 is the one that has square roots of 3's and 2's in it. And which angle is adjacent to that square root of 3? The 30. Adjacent means next to. So the angle that is next to that square root of 3 is the 30, which we said before is pi over 6. Questions?
This is right. Do we have to show all like the triangle if we're doing this? Like,
you do not have to draw it all out. What I do is when I grab my paper, like as soon as it's in my hand, I draw everything all at once, and then I just refer to it over and over. I don't draw it for every
that's what I
problem.
would do.